Hi everyone. So in this video we will be discussing about the transport layer. Transport layer uses the service of network layer, which means if transport layer has to forward some packet, then it will be like packet will be passed through the network layer. So it is using the service of network layer. And at network layer I have the protocol which is IP. So whatever the transport layer protocol we are using, they uses the services of IP, right? So, but why we need the transport layer? Which means that we already has reached to the host, we already have the delivered to the host. Then why we are needing the transport layer? So the answer of this question is that we have reached to the host, but there might be multiple processes running in the host. So maybe there is one process that is, let's suppose, HTTP. Maybe there is another process, let's suppose, FTP. Maybe there is another process, let's suppose, telnet. So there may be multiple processes running in the host, and I want to reach to the particular process. So IP address will be justifying, like, or will be reaching to just the host, not to the particular process. So there is something called port number that uniquely define the process. So every process runs on the fixed port. So HTTP runs on some well-known port which is 80. Similarly, there are some well-known processes which runs on well-known port. Otherwise, the port number will be specified in the transport layer header itself. So we do not need to worry about it. So you will get you will get to know this, which means what I'm saying, the transport layer header which itself we are having source port and destination port. Similarly, in the way that IP header was considering or was having the IP address of source and IP address of the destination. Similarly, I will be having port number of the source and port number of the destination in the transport layer header. So that will be taken care by the transport layer header. So I want to reach to the particular host, that's why I need the transport layer, right? See here, this host A is communicating with server B. So basically, if let's suppose the source port number is this, then destination port number is this. So I will be sending a packet which will be having the source port number this and destination port number this to the server. Then once it fetches some data, and once the server wants to send some data, then it will send the data, and this time the source port number will be will and like source port number and destination port number will get reversed. Basically, earlier this was this, now they will get reversed, right? I hope you got it. So this is just like IP address. Like in the IP address, I was just able to reach to this host, not within the host. So this is just like an IP address, which in the sense that it is able to uniquely determine which particular process within the host I want to reach to, and this combination, which is the IP address and port number, this combination is called gateway, or this is basically called socket, or the gateway for the process. This combination uniquely defines the process. IP address uniquely defines the host, and within the host there might be multiple processes, so this port number will define the process itself, right? Now, as you know that every layer has its own header. Like if you are using the network layer, then most probably this will be IP header. If you are using the like data link layer, then there will be some Ethernet header or HDLC header or PPP header, something like that. Depends on the protocol that we are using at the data link layer. Similarly, transport layer also has its own header, and there are generally three protocols that we use at the transport layer. One is TCP, one is UDP, one is SCTP. Now we will be like, this SCTP is just a modified version of TCP in most of the sense, so we will be studying only TCP and UDP. If you are using TCP, then like this is basically called a reliable protocol or connection oriented protocol that we will be studying. Like if you're using TCP, then this is a connection oriented service. If you're using UDP, then this is a connectionless service. So we will be studying this in the future videos. So let me start with UDP. Now UDP, as I said, is a connectionless. So what do I mean by connectionless and connection oriented will be clear when we study TCP, because TCP is a connection oriented protocol, and there we basically first establish a connection before sending the data. But in the UDP, it's just like sending the data without even asking the server or without even asking the client. So we just send the data without any connection establishment. Right? It's an unreliable protocol, just like IP protocol, which means it does not having flow control, not having error control. So this is completely unreliable protocol, which means that it does not add anything to the services of IP except for providing process to process communication instead of host to host communication. So like IP is also unreliable protocol, this is also unreliable protocol, and it does not add anything. So just one thing that it adds, which it just helps to reach to the particular process. So it helps to reach to process communication. Now this is the header of UDP, and there are four fields only, and this is a fixed size header, which means there is no variable thing, there is no option, and this is a fixed size header. If you look at it, then this is 2 bytes and the complete is 4 bytes, so there are two rows. So I will say this is a 8-byte header. Now source port number is 2 bytes, destination port number is again 2 bytes, total length is again 2 bytes, and checksum is again 2 bytes. Checksum here is completely optional because this is a unreliable protocol, so this is completely optional thing. And as you see, the total length is 16 bits or 2 bytes, which means maximum number that you can represent is again 65535. And the header length is always fixed, which means 8 bytes. So you do not have any header length field, you just have the total length field. Now if you can represent this, the total length could be 65535, then it will be ranging, the total length will be ranging from 8 to 65535. Why? Because 8 bytes are fixed for the header. So that's why the total length will be ranging from 8 to 65535. Now let's solve one simple question about the UDP. So they have given the UDP header, and what they are asking about the source port number. So the source port number is basically initial. If you just look at it, these are the initial 16 bits, which means initial 2 bytes. So this is 1 byte, this is another byte. So the source port number is basically CB84 in the hexadecimal. If you convert this to a decimal, then it will be 52100. This is the source port number. Now what they are asking, the destination port. Destination port is next 2 bytes, which means this one. So the destination port is basically 000D in the hexadecimal, which is nothing but 13 in the decimal. Now they are asking about the total length. So total length is, I think, just the next field after the destination port of 2 bytes. So this is 1 byte, this is 2 bytes. So the total length will be 001C in the hexadecimal, which means if you convert this into decimal, you will be getting 28. So which means 28 bytes, right? So total length is 28 bytes. And what is the length of data? So can you calculate it? What is the length of data? So if the total length is 28 bytes, so data will be total length minus 8, because 8 is the fixed size of the header. So it will be 28 minus 8, which means 20 bytes. So that is all about the UDP header, and UDP header is very simple. Now we will be moving to the TCP, and TCP is bit detailed. So let's just go to the TCP, and in the UDP we just have this much.